it says, uh, welcome to this live. That's when I can see my response is real fun. There's also make sure to set on my sound is audible. Consider it just comment on the text if you can hear the sound. Okay, how about now? Testing 1 2 1 2. Is the sound clear? Testing 1 2 1 2. Is you able to hear me now? Testing 1 2 1 2. For those who are already joined us on the stage, can you please just wait 5 more minutes for others to join in? I think people are having problems with connection. We started with 12 viewers, now we have 3. So I think people are having problems with live streaming us. So can you just please wait more 5 more minutes? We will start at 20:15. Meaning character phase will start. Just wait for others to join us. I think there might be a problem with connection. And then at 20:15 will start. Okay, so then I can see you're still having problems with audio. My mic is letting me down. But let me try something in the meantime. To switch mics and then we'll take it from there. Testing, testing, one, two, one, two. And I think I hope there's some good better now. Testing, one, two, one, two. Am I audible enough now? Speak for my headphones. I'm hoping that will make a difference. Bokamullo, can you hear me now? Bokang, Bokamullo, can you hear me now? Bokang, Bokang, I think now I should be audible enough so that we can start. I can see the time is already 2016. For now, we have 12 people who are viewing this live stream. I think we can begin now. Bokang, Bokang, I think now I should be audible enough so that we can start. I can see the time is already 2016. Okay. No, thank you for the responses on the live chat. Yeah, I think now we can begin. Welcome to our very first live stream. So what I'm going to cover, we already did this in class. This is simplifying algebraic fractions, especially when we are dealing with addition and subtraction. We already covered the basics in class. I'm just going through the basics, not the basics. I mean, I'm just going through the examples again, just to repeat, and hopefully, maybe there'll be a bit of understanding from now on, because this topic will be there in our assignment. We still need to write an assignment, and it will be written sometime. I'm not sure, but definitely not next week. Definitely not next week. And this assignment is separated from the test that you're gonna need to write. Unfortunately, I cannot show my face. The software that I'm using, it records the voice and the screen that I'm using. So you'll have to follow my voice and follow what I'm doing on the screen. I know you're missing this lovely face of mine, but if we can just take a breath. Yeah, just take a break from my face. You'll sit on Monday again. So let's begin. Now the views is 14 people have joined us. I think we can begin now. So what you see on the screen, these are the examples that I'm going to do. And then I will also give you time to write a couple of exercises, but please don't use my book. Just use another piece of paper or scrapbook that you have somewhere, because basically this is the repetition of what I've already did in class. So just use a scrapbook somewhere, and then yeah, we can carry on. Okay, so I'm going to start first with the first one. Let me just move this out of the way. Yeah, so I'm going to start with the first one here, which is 1 over 5 plus a minus 1 over a. And then remember what I said in class. We said when we are dealing or when we are trying to simplify these algebraic fractions, the first thing that you need to do is you need to make sure that your denominators are the same. So if you look at the denominators here, we have 5 and we have a. Therefore, we need to make sure that these two denominators are the same so that we can be able to simplify our expression. Now, okay, let me rewrite this question. We have 1 over 5 plus a minus 1 over a. Therefore, if you look at this expression over here, we have 5 this side, but we are missing a. Therefore, I'm going to multiply by a over a. And then this side, we have a, but I am missing a 5. Therefore, I'm going to multiply this by 5 over 5. Now, we're going to say a multiplied by 1, and this will give you an a. And then we're going to say a multiplied by 5, and this will give you 5a. So I'm basically multiplying these two over here. A multiplied by 5 is 5a, and a multiplied by 1 is a. And then from there you have plus. Then over here in our numerator, this part, we are dealing with a binomial. Therefore, what I encourage people to do here is to use the bracket. So just put this in brackets so that you can be able to FOIL, meaning you're going to FOIL, say 5 multiplied by a, and it will give you 5a, and then we're going to say 5 multiplied by 1, and this will give you negative 5 all over. And then now we're going to multiply with this 5 multiplied by this a, and then we will have 5a. Now, as you can see, our denominators are the same. Once our denominators are the same, you only write one of the denominators, which is 5a all over, and then you are going to write this numerator. You're going to write this numerator here as it is, meaning uh, you're going to write a plus 5a minus 5. Once you have that in place, now you need to add the like terms. And which one are our like terms? A and 5a. These are our like terms. And we are going to follow the operating symbol, the operator. The operator in this case is plus, meaning we need to add. So it means I'm going to add a plus 5a, and this will give you 6a minus 5. This will be all over 5a. And this over here, ladies and gents, will represent your solution. This will represent your solution. And then by doing so, you have simplified your fraction. You have simplified it because if you look at the instruction here, the instruction says simplify to a single fraction. Therefore, this over here, it represents your single fraction. You have simplified that. So this one is just a basic. Repeat, this is just the one that they give to learners at Selborne. When they arrive in the morning, they give them this one just to warm up. Now let's go and do the one for grade 10s. Let me just move this out of the way again. Now I'm going to do number B. I'm hoping number A was clear enough. Number A again, let me just rewrite the question. We have x plus 1 all over x squared plus x squared minus 1 all over x to the power of 3 minus 2 over x. Again, we need to start first by taking our denominators. We need to make sure that our denominators are the same. Now let's go and check what we have in the denominator. In this case, we have x squared. In this case, we have x cubed. In this case, we have x. All of these denominators, they need to be the same. Now, how can I make them to be the same? You check. So say if this is x squared and this is x cubed, how can I make the x squared to become an x cubed? Therefore, we're going to multiply this by x over x. This is x cubed, so you leave it as it is because it's not going to change to anything. But this side here, you have x. Therefore, this x needs to become an x cubed. So you're going to multiply by x squared over x squared. Just to make that to be the same. And then once you are at this particular point, I encourage again to put these binomials inside the bracket. Let's just put these ones inside the brackets so that we don't forget it that we need to find. If we're going to say x multiplied by x, and this will give you x squared, x multiplied by 1, this will give you plus x. And then we're going to say x multiplied by this x squared, this will be all over x cubed. My handwriting, because I'm not used to writing to this tablet that Mam Tombini borrowed me, so excuse my handwriting. Plus, and then this one here, just leave it as it is. It is x squared minus 1 over x cubed. And then we need to multiply this one by that one over here. It will give you negative 2x squared, while x multiplied by x squared, this one will give you x cubed. Now that our denominators are the same, if we take our denominators, we have x cubed, x cubed, x cubed. Now we can begin the process of simplifying. We can begin the process of simplifying, where now you are going to have, okay, uh-huh, okay. Now we're going to write one of them as x cubed. This will be all over. This is x squared plus x squared minus 1 minus 2x squared. Now we need to look for the like terms. Let's look for the like terms. Let's identify the like terms. X squared is the same as this, x squared is the same as this x squared over here. Meaning x squared plus x squared, it is 2 minus 2x squared, then you are left with 0, meaning the x squared are going to cancel. Then it means you are going to be left with, sorry, then it means you are going to be left with x minus 1 all over x cubed. And then you have simplified, you have written this expression, mm, yes, you have written this expression as a single fraction. You have simplified. And then in the meantime, um I just want to check the WhatsApp group. I'm just checking the chat to see if there are any questions or to check if whether everything is still clear by now and if whether I can proceed. So let me just check. Okay, so I don't see anything from the chat with regards to questions. I don't see anything on the WhatsApp group. That means I can still proceed. That means I can still proceed. Again, if you don't understand, remember this video is recorded, so you can just rewind and go back and then take where you don't understand, and then hopefully things will become much more clearer. So let me just remove this one so that we can do number C. Number C. Okay, let me just move this one out of the way, and let me bring number C down here. Okay, so currently we are standing at 14 live views. Yeah, I'm assuming other people don't have data, but it's fine. I'll hotspot them on Monday. So let's continue with number C. Let's continue with number C. Okay, let me just revert the question. Let me just revert the question. The question here is x plus 1 all over 3x squared plus 3x minus y all over 4xy minus 5 over 6y. Again, the challenge is we need to make our denominators to be the same. So you start first by taking, in this case, we have numbers mixed together with variables. So I have a 3 here, I have a 4 here, I have a 6 here. These numbers need to be the same. It means 3, 4, and 6, they will meet at 12. Now, in order for me to change the 3 to make it a 12, this 3 over here, I need to multiply by 4 over 4. That's the first thing. And then this 1 over here, because it's a 4, it will be needed to be multiplied with, okay, let me just try and check if I can move this just a bit to the side. Mhm. Uh, this over here needs to be multiplied with 3 over 3. So that 4 multiplied by 3 will give you 12. And this 4 multiplied by this 3 will give you 12. This 4 multiplied by 3 will give you 12. But then I have this 6 over here. It also needs to become a 12. Now I need to multiply this by 2 over 2 because 6 multiplied by 2, this will give you 12. Now let's come to variables. This side we have x squared. This side we have x. It means, and this side we have nothing, we don't have x. So it means this x needs to become the x squared over here, this x squared. So it means I need to multiply, okay, let me just make a space and move this to the side. Um, let's move it to the side here. And then it means I need to multiply this x, it needs to be multiplied by x over x. Why? So that x multiplied by x, it will give you the x squared over here. And then this side, I don't have anything. It means I don't have x, but I need to have an x squared. It means I need to multiply this by x squared over x squared. Now let's look at the y. I have a y this side, I have a y this side, but this side I have nothing. It means I need to multiply here again by y over y. Now, once we have this, now let's start multiplying. Let's start multiplying. Let's see. Now you can say, uh, let's put this again in brackets. Let's put this binomial expression in brackets. 4y. This 4y over here is my 10. Okay, here's my 10. This 4y over here, it needs to be multiplied here. So we're going to have 4y multiplied by x plus 1. This will be all over 4y multiplied by this, it will give you 12x squared y. And this will be plus, and then remember we have a 1 here. So let's just leave this one as it is because there's nothing to multiply with except for the 1. Oh, no, I'm lying. We have this 3x. This 3x needs to multiply this. So let me just correct it there. Let me just correct. So let me just correct. It means we're going to have 3x multiplied by 3x minus 2y. And then in the denominator, we're going to have 12x
squared y. Where's the 12x squared coming from? It comes from 4 multiplied by 3 is 12. X multiplied by x is x squared, and the y is the y as it is. Then you minus this 2x squared multiplied by that one, it will give you okay, you already have a minus. Sorry, let me just erase this. It will give you 10x squared all over 12x squared y. Now that our numerator is our denominator, I mean, is the same, 12x squared y, 12x squared y, 12x squared y, you only write one of it. You only write it as 12x squared y all over. This is all over. And then you multiply 4y multiplied by x. This will give you 4xy. 4y multiplied by, okay, I'm not sure what's happening. 4y will give you plus 4y. And then 3 times 3x times 3x, it will give you positive 9x squared. 3x times y, this will give you minus 3xy. And then this negative multiplied by that, it will give you negative 10x squared. And then we just leave everything as it is. And now we need to identify our like terms. We need to identify our like terms. So let's see. I'm going to identify my like terms. Let's see, 9x squared goes together with minus 10x squared. And then